So guys, I thought I'd just hang out here. This is not planned, so anyone who joins, we can do a Q&A. Just hang out, and I'm happy to answer any questions about the new 3D printer or anything related to DIY 3D design, 3D printing. We can have a look at the 3D model of the wee baby. I'm still looking for a name to this printer. I think we need a proper name for it. It's kind of a code name now, the wee baby, as it is a smallish printer, and it's kind of the descendant of the Wii King, which was my previous design. And yeah, so I'm gonna go through, I think I'm just gonna go through the 3D model from start to finish. Probably gonna stay here for an hour. We can look at the changes I've done, so this can be sort of a change vlog as well. I think we have most parts in place, and if not, I will probably find the missing pieces in during this time being here. Let me know if the sound, if there's something wrong with the sound or the image quality. I'm not sure I can do much, but let me know anyway. Then we can quit. So I'm gonna do a PID tuning. If you don't know what a PID tuning is, I just changed hot end on the V-Baby, this 3D printer you are seeing now. And the new hot end has another thermistor. I had heater issues with the previous hot end, the mellow hot end. I'm not sure, I'm not saying it's the hot end, but this mellow hot end has a totally different thermistor. It uses table 13 in Marlin, which I've never used before, so I don't know this thermistor. I find it a little bit strange, and when cranking up the temperature to, let's say, 220, 230, it starts to give me heater failure. It might be a firmware issue, or it might be a table issue, a thermistor table issue. That's the same as the firmware, but I also previously had some firmware issues with other thermistors, so I don't know what this is. But anyway, I changed to the NTC 3950, which we all use. So I put that on, and I'm gonna do a PID. We need to do PID tuning when you change hot end anyway. Any new hot end needs PID tuning. Okay, if you change, let's say, from a V6 E3D V6 to a E3D V6, you're pretty sure that's the same. You can use the same PID numbers. But if you change from let's say AliExpress V6 to AliExpress V6, then I would probably do a new tuning just to make sure, because there might be some difference in material. If the material in the hot end have different alloys, it's not from the same, family, then the PID will be different. So that's important to have in place, and I can show you how we do that. Let me bring up PID tuning for you on a website. It's pretty easy stuff. So hello Scott, by the way. Yeah, you're right about it's about I think it's more about temperature than, let's say, material related, but you are saying, Scott is saying that we need to change PID when we go from PETG to PLA and vice versa. That's it's yeah. If you're really like want to get everything like perfect, then you do that. Or else you can find something in between. Let's say you PID tune at 220, which is kind of in between 200 and 240. Then you will probably be fine at 240 and 200. Or else you can of course have these numbers in your start end code. You can put 301. You can put M301. I'm gonna show you in if you can see that. Let me bring that up. When you find your PID numbers, you can of course write those down and put the M301 P and your number, I and your number, and D and your number in the start end code. I can show you how we can do that. If we go to Cura and I go to the baby, go manage printers, go machine settings, I can of course for extruder 1 I can set M301 then P and then let's say 10 I, so let's say 1 and then D 100. I can do that. I'm not sure if we can put it here. Do you know if we can put it there? Or we can put it here at least anyway. But then you need to change it. If we have several extruders in defined in Cura, like I have here, I have two. I have one 05 nozzle and one 04 nozzle. Probably could have, let's say, another PID number here than we do here. So that could be an option if you are want it to be like all NASA standard, which we like. But to be honest, I on my Vikings, which all run E3D V6 genuine hot ends, I do tune at the temperature I use the most, which is PETG or CPE. So I typically tune the temp at 240. So you're correct, Scott. Yeah, can be start. Thanks for that. I've not really used these start codes in the extruder start codes. I guess that's fine. We can also maybe set C offset here. Could we do that, Scott? Can we have like M851 and then C minus 1.9 and then let's say another one. That's how we set our C offset. M851. Then the negative, let's say 1.95 or something here. If it's a different nozzle, we need different C offset. So that's also important. When you change hot end, you need to adjust your C offset. So this is all interesting. I don't know all the details about this, but at least I know how to PID tune and set my C offset. So we can do that now. Let me bring over pronter face. If you don't have pronter face, you should have it. I am now connected to the printer. So by USB connection, so I can connect directly to my printer. So I'm just gonna hit connect here, and I cannot connect, which is kind of funny. Oh yeah, this is very annoying. This is so typical, and I do it over and over again, and it makes me crazy because yeah. typically when you have Cura running, it connects to the printer right away. So you cannot connect by Pronterface or anything else. So you need to close Cura and or all other stuff. Yeah, I think so, Scott. Now we are online, and what we can do first is I can call up my M501 just to have a look in my settings. I don't know how well this comes up on screen, but here are my settings, and I currently also we can start with that actually, the first change I did, because I heard lots of great stuff about the LV extruders, the LV8729 I think the number is, and I have had a few of those laying around, and I have had lots of issues with my extruder, and I thought it was the board. It turned out and then I thought it was the drivers. It turned out it was the extruder motor, which was basically gone. It was dead. So I changed that, and but at the same time I changed my extruder driver to the LV, and running that on 128 microsteps, which makes it quiet. What are you saying, Scott? Okay, there's a setting in Cura not to connect. Do you mean not connecting? Yeah. Anyway, we are fine. We are connected, and we are going to do PID tuning. Let me. I'm traveling back and forth here now. This is just a hangout, so excuse me for that. But PID tuning. Let's just get that started. This is important. Everyone with 3D printer must know PID tuning, and you need to know the numbers on the screen. I don't know if I can blow this up. These are the numbers you need. M303. M303, and then E for the extruder. If you have more than one, then it's like E1, E0, E1, and so on. S200 is the temperature, and C8 is how many cycles you want to run. Typically you run 8, but you can do more, of course, but do at least 8 cycles. You can do 10 or I don't know, 16. Just a minute, Scott. I will get back to the chat. I need to start my PID tuning. So I'm just gonna copy the line and paste it into Pronterface. I know this window is very small on the screen. I don't know how I can make it bigger. And I'm gonna change the temperature because I want to tune at I don't know what I'm gonna tune at. Let's just tune at 210. This machine is probably gonna run mostly PLA, but I'm also thinking of making, because I want to make one more. I want to make like the first production release model of these printers, and I probably want 10 of them. But I do. Yeah, so probably it would be nice to print the parts with the printer itself. So we have the rep thing going, and then I would need higher temperature, but then I can do that later. Let's now just tune for PLA and do it at 210, because some of my PLA do run at 230 actually. So I'm gonna just hit send, and now it's gonna start doing its thing, and that's gonna take a while. And it's gonna go up, let's say to 220 or something, and then down and up and down and up and down. I don't know if you can see the. You can barely see our extruder temperature. We're now at 82. Yeah, we're at 100. So increasing. But we don't need to watch that. We can have a look at. I'm just gonna have a look in the chat, and then we're gonna go to the 3D model. Okay, thanks, Scott. I didn't know about this setting in Cura to not connect, but now I don't want to open it because I don't want it to like take over something that's going on. Even though it shouldn't while we are connected with Pronto Fate, I don't think it would like actually take over the connection. But let's go to. Are you building the Viking or the Wee Baby, Scott? Or are you building any of them? I think yeah, you did. Let me know. I don't remember now. The baby? Yeah, fine. Good. Okay. So let's just start from the beginning. I'm gonna travel back in time. Are you happy with the parts you are printing, Scott? Are the parts coming out fine? You're printing in PETG or what you're printing in? I mean, some of these parts could be in PLA. I know I make it hard for people to print them in PETG. So we can talk about that as well. Is that what kind of printer did you have printing those parts? I can see there are more viewers, so please join in the chat. The ANET. Oh, interesting. So I'm actually gonna open up. I mean, any machine, any 3D printer, it's just really a machine melting plastic, kind of in an advanced way. I mean, all 3D printers are basically the same thing, doing it in different ways, and it all depends on the mechanic, I guess. If you're a good mechanic, then you can get any machine to print good, I'm sure. At least if you don't run too fast. You know, everyone is so concerned about this speed. Everyone, how fast does it go? It's just silly when you have when you are dealing with 3D printing. You should have some patience. I don't have that myself, but you learn to be patient, I guess. So this is the base frame. Oh, more people joining in the chat. Good. I'm just gonna have a look in the chat. New people arriving. 3D poop. Yeah. Thanks, Divas. Okay, so there's nothing exciting here in like the base frame. It's just like aluminum brackets. Actually, I replaced this guy. This bracket I added something for our cable loom, so I made one in plastic. We can look at that later. That's like I guess it's an option. It's sort of in the bill of materials. But if you don't want my cable loom solution, then you need aluminum bracket here. Okay, let's close this guy. That's not so exciting. This is more exciting. This is like the first step in adding parts, adding printed parts. Did you print the worm drive bracket, Scott? Because I changed it. You can still use, if you printed it. I just made some changes to it. There's something wrong going on here. What happened here? I need to have a look at that. Good thing I noticed. Nothing wrong with the part, just my assembly. Something wrong. Let's have a look at this. Let me fix this assembly. Okay, so it looks fine here. So what I typically did, we can open like the previous one. You can see what I did differently. Worm gear. Here is the worm gear. And we can open number. Open this guy maybe. So I just moved the anchor point really. This is the previous guy. So we don't need this this part anymore. Actually it simplifies a lot because this was sort of in the way. And now we can just have it like this. Easy peasy. And I'm gonna show you how we are going to attach the belt, because the belt was attached there before. Just have a look in the chat. Yeah, you, as I say, you can still use, you know, the previous one. This is just simpler, basically. And let's travel back in time to this guy also, because I can see that it doesn't, you know, Fusion has a tendency of messing with joints. So sometimes it doesn't apply as it should. Here it is, as it should. That's nice. Nice of you to come by, Dimos. See you later. Okay. So that was, yeah. Let's start from the top here. We can also travel back in time here and just go quickly through the whole thing. So we have the motor brackets. There's sort of a A and a B of those. So this is my A motor bracket. And there's nothing special with that. It has not been changed for quite a while, at least. We'll look into some reverse engineering later, Dimas. I'm up for that. And this is the B, so we can add those parts. Actually, I like to add these parts while I assemble the frame itself, because that's why we have these extrusions are tapped, because I'm using this screw into this extrusion, so we can align everything. It's easier to get these L brackets in place where they should be. So if you do assemble these printed parts together with the aluminum L brackets, then it's easier to get everything aligned, I think, if you have the possibility. But just remember, if you do assemble these guys, you need to put the bolts and the idlers inside, or you have to take them off again. Of course you can take them off again. It's not like a big task to take this off, and then you have them all aligned and they are attached with the L brackets, the 90 degrees guys. which is fine. Let's have a look at the prompter phase. I think our PID tuning is done. So here, yeah. I'm sorry for jumping back and forth, but we need to do this before it times out or something. That have happened to me before. So we have our numbers. I don't know if you can see them. The numbers are P 18.28, I 1.33, and D 62.66. So now we want to add those numbers to our firmware. And the way we do that is we use M301 and then we put in the numbers like this. So I'm just gonna write M301 and then P and my number 18.28 and then space and I 1.33 space and D 62.66 and then enter, and we need to save it. Most importantly, save it M500 or you will lose it the next time you turn on the printer. And then we call it again with M501 and then it should turn up in our readings. So we have the numbers here. These are the numbers we just put inside. So that was PID tuning, that was easy peasy. Now we should print something with this hot gun because that's all new, and I'm a little bit afraid of that the nozzle is has been not destroyed, but it's maybe been hurt. I actually had a big crash. I always crash something. At some point I will crash my printers. If you haven't crashed your printer yet, you just wait. You will at some point crash your printer. And yeah, so and it's very strong. This machine is very strong, I can say. We can actually engrave with this machine with just the nozzle. I made a big I digged into the aluminum with the copper nozzle. Or is it bronze or is it copper? I think it's copper, yeah. Anyway, so I had to like refurbish my aluminum bed to sort of even out the big the big engraving I did with this machine. Okay. Let's walk through. Let's keep on walking through the 3D model. So these are the printed corners. And what have we next? The idler top. Okay. So this is our upper point for the C belt. So here's the idler. There's one thing I might need to do. I have not done this yet. I might want to change the space between here. Because let's have a look at the space we have between these walls. We have 11 millimeter. That is a problem for me when going to the expensive idlers or the good idlers. If you didn't see my YouTube video about good idlers, then I cannot link to that now. But it's I think it's a previous video. They are wider, and I do want to use the shims, and the shims are 1 millimeter each, and the good idlers are 10 millimeters. So I will, not probably, but I will change this part so it's wider. It will not really affect anything. You can still use the 9.5 millimeter idlers. But at least then we have space for the good idlers, which I think is important, as I do preach for those. I think those are worth the extra money. Probably the most annoying parts to have bad on these printers are the idlers squeaking and not running right. Even though it might just print fine with the, you know, the bad idlers, but yeah. Anyway, I would like to have the good ones in there. I'm talking too much. So let me just change that right now. I can show you how I do this stuff. I just want to open up, let me travel back in time here. Let's see what's going on. So here is where we need to change stuff. So what I need to do is I need to make this 12. But then we need to make sure, probably we don't have, okay, so we have 4 here. Okay, good. Yeah. Good. I like my walls to be 4mm. There's many reasons for me to have 4mm walls. Any wall, like structural wall, should be at least 3mm. If it's not structural, then of course it can be thinner. But 4 is nice. 5 is also okay, but sometimes it's a trouble using 5 because of using let's say you use M5 screws, and if you do use a washer and you want them into the V slot or the T slot, then a 5mm wall might be too thick. So it's like a very delicate thing to deal with. So here also is something I need to change. Let's just do this -4, like that. And just mirroring these guys, and then the rest should be basically the same. Yeah. But I can see we don't have a bolt here. Why don't we have a bolt? We need that bolt in our bill of materials. There you can see it's very nice to go through the whole machine from top to bottom. We need a bolt. I need to measure how long this bolt's going to be. So we need 20, then we need it M5 by 25. Let us grab that. Going into the hardware, the M5 folder, and M5 by 25. And this guy, we don't really need a washer for that guy. It's not going to be tight at all. So let's just add that first, and then we can do the nuts. It can be like this. I would like to have a washer on the nut side. If you find it hard to do joints, then hit Control and point, and you will find your point easier. And a lock nut for these. So that's gonna go here. And if it comes in the wrong way, you just hit flip. Yeah, it's barely long enough. I think actually we would need... here you can see, this is very details, but I want this to be right. We cannot use a M5 by 25 here. I already see that. So I need to get rid of this one. And pick M5 by 30. This is important stuff. I'm picky when doing these things, but I think it's important. And then since this is long enough, I will probably just use a washer on that side as well. So let's just pick this guy. Control C and Control V. And add that over here, and then do another joint here. Okay, here we go. So that should be it. And then we have to, of course, we have to bring this into our repository. So I'm going to Tools and then Make. Then we need to save it. It's probably gonna be the same name. Idler top rear body. Support no, brim no. So I need to save it. The thing is that now when this is saved, I need to I need to turn it around, but because it's not printing. It's not printing like that, and I know that you guys, many of you like to have those oriented already. So I'm going into Mesh Mixer, and I hit T for translate, and I just grab one of these angular things and go a little bit outside and just turn it 90 degrees. Like that, and hit accept, and then go edit and align and accept, and we are okay, and export and to the same guy, and now we are done. So I need to account for this on the other parts as well, and I already have thought about this when designing the printer, so we might actually have space on the other parts. I didn't on this part, but I can look into that later. I'm not gonna go so too detailed now. So are there any questions? Sean, welcome to the party. Yeah, if you have any questions about Fusion, then let me know. I'm not saying I'm an expert, but I figure stuff out, sort of. So we have a few more parts in this stage. Let's just walk through them quickly. So the next is the idler body, the worm drive, excuse me, the worm drive body. And then we have, what's this? Yeah, so, oh, yeah, that's also important. There was a change to this part just yesterday. I need to move this idler. Now we need to check also this idler. If we have 12 millimeter here, we only have 11, but that's okay. Actually, we don't need to change that, but because this idler is not a moving idler, it's just the attaching point, actually an anchor point, and we don't need the spacers. So let's just leave that alone. But the change I made was this hole for the idler was too far to the right. It was too far over here. I did not account for the thickness of the belt when placing this idler. So the belt has a thickness about 0.75 on the toothed side and 0.63 on the smooth side. So now this is accounted for, so we will have a straight belt path. And then, what's the next guy? Yeah, okay, so I recently made a new extruder bracket, but this is also, if you want it on your, let's say, backside, then you can use this. It's still in the repository. I think I want mine on the front, and the bracket needs to be a little bit different. And here is the guy I was talking about earlier, and those of you who just arrived, this is my cable loom body for the frame, and it also acts like a corner bracket, so you can exchange the corner bracket with this guy. This actually works quite good. So we have one M3 here. It consists of two parts, the corner bracket itself and then the loom body. It's a M3 here and one M3 here. And this M3 I made like a long one, because you can, if you want to, you can thread a PTFE tube onto this guy, and then you have sort of a guide for the cables inside the loom, which can be nice. Then it sort of stands up a little bit. Okay, next part. So this is my front extruder bracket, and we need to bring it outside a little bit, because or else the motor will crash with the hot end or the BL touch. That's why it's like different. So we can have it on this side or on this side. What I like to do is actually have it on this side and not over here. I'm talking about if this is our center part, and I like to have it on the left side. I tried both places, and it's better to have, I think it's better to have the spool on the right side, because then we can watch our homing or else the homing is behind the spool. Just details again, but yeah, you know how I am. And then we have another important change. So this is the part, it's just one piece part, very easy to print. Prints beautiful, no problems. The anchor point for the C belt, because we are now running the belted C drive a little bit further than we had before. And I'm gonna talk about that a little bit later. This part is new and it's in the base frame repository. So just basically a loop that you travel your belt around, and you have this fixing point. Then we have the tension guy up here, which is the upper like anchor point, and then the lower anchor point down here. It actually makes things easier for us. And that's the last part in this assembly. So that's nice. Any questions, guys? I don't know, I see there are some viewers, and any questions about this thing or anything else? Let me know. It can be 3D printed, it can be it can be 3D print related, or it can be just about 3D design, whatever. So let's have a look at our top assembly. I'm sorry, I can't seem to share this top assembly. I tried to share it, but it all fails. It's not my fault, really. I have it shared, but it doesn't show up. Maybe it's too heavy. So this is the X-axis, X-carrier and X-axis assembly. There's nothing new here, but I want to talk about I want to discuss something that is an option to do. Yeah, first of all, this flag is quite new. I don't know if you have seen this flag before, but it's for the optical X stop. And also made some small changes to this guy. It's quite a while ago. I just made a hole, actually, another hole. You can drill, you can bore. Make a drill bore. What's it called? A bore? A drill? I don't know. Make a hole anyway into this guy, so you can attach the lower M3 here. And you don't need a nut for that. You can just like. If you use a 2.5 millimeter bore, then you can drill, then you can just screw it directly into. Hello, Master Steel. So we have a little bit of lag here now. I'm sorry about that. This is Fusion getting heavy. When it starts to get heavy, it starts to lag. Even though I have I have a gaming computer, which is supposed to do this very good. I have the HP Omen. Yeah. So let me open this XSC because I want to talk about, ask about something regarding direct drive. I know some of you are really into direct drives, and I want to talk about that because I've been researching direct drive option for this printer and how we can attach something inside here. You know, if I open the X carrier, then we could like take out this part. We need to remove like all these guys, and then we could have, you know, our direct drive inside here somewhere. But there is one problem, and let me bring my BMG direct drive so that you can have a look at that. So this is what Mello sent me. They actually sent me this thing. They asked if I could use it. It's a left drive, I think. At least it's the opposite direction than what's normal. And this guy could be used as a direct drive. You know, you just add a heat break here, and this acts like as a heat sink. This guy. It's very heavy though. I have a pancake on. And it seems like a decent engineering, so it would be nice to utilize it. But the thing is that this guy is same size as the NEMA, and the NEMA is 42 millimeter. So we need 42 millimeter, guys. How much space do we have between the fans? We have 40, and if we account for we need to attach the fans as well, so we actually need to account for some bolts here, and then we are like 36, and then we also need some air between, so we can't be touching, which means that if we were to you cannot see what I just did. I forget to transition, I'm sorry. Here you can see what I'm talking about in between the fans. So between the fans we have 40, and between the nuts we have 36. So it's too tight. So if we want to put this thing inside here, in between those fans, or we must take off the fans. So it means like we don't have space really. We need to redesign the whole thing. The whole X carrier needs to redesign. So is there another option we can use? How can we get this thing to a direct drive? I'm gonna have a look at these. Let's measure between our bolts, our holes here. Sorry. Let's measure between this guy and this guy. So we have 40 millimeter between those bolts, which mean they should also probably be wider. Even though if we just, you know, get rid of the fans, we could take off these fans, then we still have an issue because these bolts are too close, which means we need to redesign. The X carrier itself needs to be longer, actually. Needs to be wider. The wheels, not the wheels, but yeah. We need at least 2 millimeter more. Nimble. Bart, who did allow you to this live stream? I cannot remember inviting someone called Bart Van Rees. I remember, Bart, you said that you were not happy with the Nimble. I don't trust this flex drive, to be honest. I don't like the flex drive. I don't want to use the flex drive. But I do want to accommodate for direct drive here, and I probably should have done that earlier in the design process, because now I see I have very it's very tight space-wise. So maybe we can do. Actually, it might be possible with something like a E3D solution, Titan solution. I have to look into that later. Yeah, that's also something to consider. Sig Elliott, to raise the thing, have the hot end like down there, and then have the motor a little bit further up. Doesn't need to, like, the extruder doesn't need to sit on the hot end really. So we can look into that. But I can come back to this when I want to first make this project, like, release it, and then we can I can do some direct drive for it. I really do want to accommodate for a direct drive, so let's make that happen some way or another. Maybe I just design another X carrier, because it's very easy to change this X carrier. It maybe takes half an hour, maybe max, to change the whole thing, really, because the fork is still sitting on, so we just pull the X carrier. You have to, of course, take the belts off. Okay, let's move on. I'm not sure what you're talking about, Sig Elliott. I'm not sure what part you're talking about flexing. Sig Elliott is talking about his V-Baby flexing. The A-axis. Oh, the this axis. The X-axis, or? I'm not sure what you mean. I don't know if you guys see the chat. We're not going to go into details there. Let's move on with our... so no big changes here, really. Let's just have a look and see if we can use the good idlers here. I think we might be lucky. What we need is 2 idlers. So we have exactly 20 millimeter. That's not enough. We need 22 millimeter, which means I need to make these guys higher. Let's just do that right away. I need to make these guys higher. I need 22 millimeter here, because we need 2 shims and 2 10mm idlers. So let's travel back in time. And here is where I want to make a change. So let's make this. You can see I have done some calculations here. I actually used, you know, I have been totally wrong in my idler calculation because I did think I accounted for the good idlers, but I've been using 8.5, not 9.5 for the idlers. So let's just put 22 in here. And 22 is tight, then we don't have any air, we don't have any space for nothing else. So we probably should I don't know. Let's have a look at what kind of bolt, because this is also something comes into play here, is what kind of bolt we are need to use for the idlers. Now you can see the bolt for the idlers is too short, so we need 2 more millimeter, and this bolt is M5 by 30. And we cannot get something M5 by 32 doesn't exist, so we need to go to 35. We can go to 35. This is starting to get complex. Let's put a washer here. I need a washer. M5 washer. So let's grab this guy. And let's release this guy. And add the washer up top, because then we don't need to add so much height. And then we can let's pick M5 by 35. So now we can see that our M5 by 35 is a little bit too long, so we need to raise something. We need 2 millimeter. We need to raise something 2 millimeter. So let's go to 23 here. Then we have a little bit of room for the idlers, for the good idlers. We can still use the bad idlers. I'm so sorry about saying the bad idlers. I use them myself. Don't worry, they are fine. It doesn't matter if there are, if it bothers us, we can make a spacer for this, but really the gravity keeps them in place, so no worries. And now we are looking for 1 more millimeter. Yeah, looking for 1 more millimeter. And I'm actually just gonna do that by pulling. I'm gonna pull something. Let's just have a look. So basically I'm just gonna pull this face up. Like this. and then we are done. Then we have then the hardware works, and our good dialers works. So now let's just check our space in between here. It should be 23. Yeah, we have 23. So these idlers, I think actually these idlers are totally wrong. 8.5, those are totally wrong. Let me fix these idlers because this is not good. We need to have right idlers in our design. So 7.5, 8 should we have them? We have 10. So let's account for the no, let's make this, let's make these like the normal idlers. People are mostly gonna use, I think, the normal idlers. So let's just have that in the bill of materials, or the actual, or the design. Let me have a look in the. I'm been away from the chat. Let's just have a look. Aha. Yeah. Flexing the x-axis. No, the x-axis doesn't flex. There's not much going on. I mean, if you have, I don't know if you have watched my live printings on the Vikings page on Facebook, because you can have a look at the nozzle, how it travels. There is like no movement in the Z direction whatsoever. It's so precise, it's like ridiculous. But a direct drive will of course be more heavy to twist. We can talk about that, but let me fix the other idler as well. Just gonna do that quickly. So I just need to refresh this assembly now. Okay, I'm not gonna go much more detailed in this session now. I can already see that we are running late. But let's just keep on walking through the assembly and see what's needed to update, as to accommodate for these idlers and other stuff. Yeah, okay. There's not really a video. I do some live streaming on Facebook, printing test objects. So it's not really something I upload. It's just very easy to do it on Facebook because I don't want them to be on YouTube or something. It's just like really bad stuff. It's just a nozzle moving around, really. Very boring. Okay, let's have a look at the next stage in the build. It sounds easy doing this live stream. Oh, yeah, I can do. Yeah, of course, I can do a live stream on Discord. Yeah. Okay, so here's also one change which is important for you guys. I know some of you were late to the party, so you might want to go back and see what I have been talking about changes, been doing lately this last week. And I'll change this part because now with our new anchor point for a more rigid bed lifting system, we need this idler as well. I didn't have this idler before. This was a different part, but the good thing now, we can use this part, the same part over here. So I removed one part and then I just duplicated. We use the same one, so this is gonna be a 2x, not 1x. Probably need to change that. That's a good thing. I totally forgot. This needs to be 2x. It's already is 2x. Huh? I probably in the bill of materials not 2x. Bed, lift idler body. Yeah. So I'm gonna remove this one. Is this the A or the B? This is the B, so we need the B and not the A. Okay, so I remove the A. Let me open this and see. I'm not sure which is what. Yeah, so this is the what we are removing. So the A is going away. And then we add 2 pieces of this guy. And this one prints. How does this print? It's probably going to print with no support. Support no, and then brim I would say optional, or maybe yes for brim for this guy. Yeah, we'll say brim yes. I don't need to resave it because it's already there. So then we have 2 of those that part. Counter-Strike, welcome to the party. Yeah, boring live videos. Yeah. It depends on who's watching, I guess. Okay. We need to move on, guys. I need to walk lucky soon. No other changes to this, or rather, oh man, we might need to change this part as well. Okay, so I'm gonna do, yeah, I don't have space for our good idlers here. We need 12mm. I'm gonna let me fix that tomorrow. I'm too tired now to do that, but I'm gonna make space for the good idlers in all the parts. I'm gonna re-upload those. Actually, I have the good idlers running on the Z-axis, but I didn't manage to put the shims inside, so they are just running without shims, and I do want to account for the shims as well. This morning was interesting. I'll tell you what happened this morning, Counter-Strike, with the live printing stream, is that it stopped, and I was at work, and I thought, well, do we have heater failure again? So I went home, and the thing is, my PC went to sleep. So I just woke up the PC, and it started printing again. But the thing is that the live stream, it times out when there's no action going. It's very strange. So let's attach the bed. I'm sure, I know some of you are still talking about direct drive. Let's just figure it out. I mean, there must be a solution to, like, maybe you say that, like, to distribute the weight a little bit or something. Because it might just get too heavy on the side. I agree. And on the electronics, also, this part is new. Because I recently I just clapped, so that's the noise. I'm using the TFT now, the Big 3 Tech TFT 2.5 or 25 or what it's called. 24, is it? 24? Yeah. TFT 24, I think. And I must say that I like it better actually than the Mini 12864. And actually the touchscreen, we can switch between touchscreen and the 12864 mode. And it's very quick, it's much quicker than the Mini tab panel. So I really like that panel. So I wanted to add that to the bill of materials. I will of course have a panel mount for both of them. If you also have the Mini panel, then we have a mount for that as well. And you can have that one. This one you can attach wherever you want. You can have it here or there or on the side, or yeah. It's so nice. And this also has USB. Actually, you can print from USB with this guy, and also SD. So that's new. Great. Yeah, the new belt path. Scott, time to get Octoprint. Sorry, Sean, I'm just gonna answer Scott first. The belt path. I'm thinking about I should probably like design the belt path, like draw it up, because it's very hard to get the proper picture, to get the proper video of that. I can try to get some pictures or a video, maybe it's easier. Probably should just draw it up. I can try to explain now. Let's talk about the belt path. If we start, let's say start up here. So this is one anchor point and we can start here. We add the belt to this guy and we have it loose, all loose. Then we go below this one and up. That's just to have some sort of tension. We go over, above, on top here, and then down. We go down to this guy on the underside here, and over. We come under this guy, and then over. This is like flying. Over to this guy, around the top of this guy, and down to the pulley, you know, on the left side of the pulley, and then around the pulley and up. Up to this guy on the back side here, around, down, oh man, now I lost it. No, I didn't. This is right. And down to this guy, and of course under this guy, and then under here. I totally lost it. I need to redo this, Scott. I'm sorry, I lost it. I don't know where it went wrong. Let me see. I go down, over, up, down. Yeah, let me do it one more time. So we start here. We go down to this one, over to this one, up to this one. So this is where I went wrong. Go under this guy, up to this guy, then down to the pulley, and then up to this one, and then over to that one, and then down here. Then we have the lower anchor point down here behind the enclosure. This guy. So one more time, trying to do it from this support now. This was very messy, I'm sorry. Now we also have a frozen fusion. So yeah, you got it. Okay, so let's not use much more time on that. Let's just now we have a few more parts. I'm waiting for fusion to, to come back to me. So yeah, I probably should get some more memory. I only have 16 gigs of RAM. I should probably have 32 because it freezes on me sometimes. That's not a good thing. We are back. I thought we were back. Still waiting. So let's keep on. I'm gonna do a proper, you know, belt path thing because that's very important. But let's move on now. So the next part, waiting for that to arrive. I think we have some memory issues. So let's just wait for that. Any questions? I can read in the chat while this is working. I don't really know how I upload stuff to Discord, but I'm sure I can figure that out. Yes, Counter-Strike. Yes, it's a good thing that the PC went to sleep, of course. But I don't know if you arrived early or late. But I have now changed the hot end to another hot end with another thermistor because I have too many heater failures, really. And there's a strange thermistor on this hot end from Mellow. So I'm just gonna try another one. So we have also the end stop buddy. The end stop buddy is also a part, and the flag might be new to some of you. Small parts, but of course important parts. I did try to get the sensorless homing to work. I did not manage to do it. They did not trigger, so either there's a firmware thing or some maybe I set something wrong on the board in some terms of jumpers and such. But here is the optical end stop, just very easy peasy part. You can use that on the C as well. And there's this flag you need on the Y carrier. Computer sleeping is great news. Ultimate performance, no sleeping. I did put the computer to not sleep now. I'm sure I did. Yes, I actually did that. We have some more parts. Just fusion is just really stretching my patience right now. I think this is why I'm not able to share this assembly, because it's getting too heavy when I add all these parts. Imagine how many fasteners we are talking about. 1000 fasteners, almost, at least 800 or something. And all those fasteners have joints, and the joints is what make this thing heavy. So let me just get these parts in. And is there anything else we should talk about? Or did I lose you all? Yeah, Fusion is still working. Do we have another name, guys? Oh, Octoprint. Yes, Octoprint. The thing is that what I think about Octoprint, I think Octoprint is nice, but I also think that it's just adding too much stuff. I don't like it. I don't like to have another board. You know, you need the Raspberry Pi. Then you need a good SD card. Then you need a power supply. Then probably you want a camera as well. And suddenly the price for the setup is the same as a Duet Wi-Fi. So why not just get a Duet Wi-Fi instead of all these parts and electronics? I don't like to have too much more electronics than necessary. And why don't we have Wi-Fi on the board? I don't understand why we need this separate piece of hardware like the Raspberry Pi. It's just annoying. I used to run Octopi myself, and I really like the software. It's really great, and you have great apps and such. I just think it's expensive, and it complicates stuff. For me, it does. For this simple printer, I don't see the use for it. You can have this attached to the computer, like I do now, or just print by SD card. Really, what's the big deal? I don't know. Yeah. So the chat. We baby is good. Yeah. Probably simple is the best. I agree. Counter-Strike. Absolutely agree that the simplest is the best. Like 99.9% of the time. So it would be nice to. I know there was one guy building one of these in 300 size. He actually redesigned it for. He used my parts for MGMs, so he has like a linear guide solution, like a baby, baby something. That's interesting. He was really happy about the XY parts, using that as on the MGNs actually. That's interesting. I think we just have to shut this thing down, really. It doesn't seem to calculate, and this is, as I say, probably why I can share this assembly. I don't know. But we've gone through. I think we've gone through the most of the changes. I'm gonna accommodate now all the parts, which include idlers. Probably you want, if you are going with like the good solution idler, then you need new parts. If you are going with the cheap solution idlers, then you can use these parts as is. So that's the only thing left for me to do. And then I'm gonna update all the fastener list, the bill of materials. I'm gonna update all the links, and I'm gonna go on a vacation. Let me talk to you. I'm gonna go on a vacation next week, and I don't know if I am gonna take the baby with me or not. Might even do that, I don't know. Maybe I should just leave it rest for a week. And when I come back, we are gonna finalize everything, make it ready to release. And I'm gonna start building the thing from scratch with the bill of materials, ordering everything. I'm gonna order the maker supplies kit to make everything easy. He's gonna cut it for us. He's gonna tap it and also deliver fasteners. So we get all the fasteners you need for the build. You don't have to like figure that out to get it from all over the place. I don't know the price for that yet, but the last time it was at 183, and probably it's gonna be a little bit more. So finally it showed up. Everything showed up. Sometimes, you know, there's one joint that doesn't work. Let me show you. So this guy, this fan on the left here, like it's stuck in the air somewhere. But thank you for joining in. It was nice to have some of you here, and I hope you enjoy, and then have a nice weekend, and I'll maybe see you next week because I'm on a vacation. I don't know. And if anything, we'll communicate on Discord or Facebook or Telegram or some sort of communication platform. And I'm sure I can help you, even though I'm on vacation. There's no problem. I'm of course watching the I'm being available. Okay, let's just end this and go met some plastic, guys. Ciao.